In this video, we're going to look how molecular mass and moles are related. And we're going to begin by talking about the formula mass. And that is just the molecular mass of a compound. Now, previously we've talked about atomic mass, but now it's kind of the similar idea, but for compounds. And what you do is that you simply add up the atomic mass of all the atoms in the chemical formula. So the formula mass is the number of atoms in the first element times the atomic mass of that first element, plus the number of atoms in the second element times the atomic mass of that second element. And you keep doing that for every type of atom in your compound. So for example, for water, H2O, the atomic mass of hydrogen is 1.01 grams per mole, or AMU. Oxygen is 16 grams per mole, or AMU. So the formula mass of water is 2 hydrogens times 1.01 plus 16, because there's only 1 oxygen. Add those together, 18.02 grams per mole, or atomic mass units. Either one of those units are fine. So let's test your understanding of this. So I want you to figure out what the formula mass of C6H12O6 is. So figure that out and come back to the video when you have it. Alright, let's take a look at this. So we know from above that the mass of hydrogen is 1.01 grams per mole. On a periodic table, we can look up carbon as 12.01 grams per mole, and oxygen is 16 grams per mole. Now we have 6 carbons multiplied by 12.01 plus 12 hydrogens multiplied by 1.01 and 6 oxygens multiplied by 16. Add those all up together and you should get a formula mass of 180.18 grams per mole. Now let's talk about mass percentage. That's just of this particular element, what percentage of its weight makes up the compound's total weight. So for example, for mass percent of a certain element X, it's just the mass of the element X in 1 mole of compound divided by mass of the 1 mole of that compound times 100%. So what does that actually mean in English? So let's look at the mass percentage of H and H2O. So H2O, the weight is 18.02 grams per mole. The weight of hydrogen is 1.01 grams per mole. Now in 1 mole of H2O, we have 2 moles of hydrogen. So we take 2 multiplied by 1.01 divided by the weight of H2O, which is 18.02. Multiply that by 100, and we should get 11.2%. All right. Let's try to do this in a problem. What is the mass percent of carbon in C6H12O6? Again, pause the video, figure it out, come back when you have an answer. Okay, let's take a look at the answer. In C6H12O6, the weight is 180.18 grams per mole. We have 6 carbon, and the weight of carbon is 12.01 equals 72.06 grams per mole. And we just divide the two. So 72.06 divided by 180.18 equals 0.3999. Should only have 4 sig figs because you have 4 sig figs divided by 5, which is 4. Multiply that by 100, and the percentage of carbon in C6H12O6, or rather the weight percentage of carbon, is 39.99%. So what's the point of doing this? Well, we can use this mass percentage as a conversion factor. So in the previous slide, we just figured out that 11.2% of the weight of water is due to hydrogen. So in 100 grams of water, 11.2 grams of it is due to hydrogen. Or another way to say that is for every 100 grams of water, we have 11.2 grams of hydrogen. And if we look at the molecular formula for water, H2O, we know that 2 moles of hydrogen are there for every 1 mole of H2O. Therefore, I have two questions for you. If we have 1.50 kilograms of water, what is the weight of hydrogen in grams? And if we have 2.70 moles of water, what is the weight of hydrogen in grams? Again, pause the video, try to get an answer, come back when you have one. Alright, let's look at how to solve this, and this is really just dimensional analysis. So I told you that you would be seeing dimensional analysis again and again, so if you're still confused by dimensional analysis, go back and review that video. But let's take a look at dimensional analysis here. So we start with our train tracks, and we start with our known 1.50 kilograms of water. The first thing I'm going to do is convert that kilograms into grams because we want our final answer in grams. So for every 1 kilogram, we have 1,000 grams. Now I'm going to convert this water into hydrogen. So up above, because of this mass percentage, we know for every 100 grams of water, we have 11.2 grams of hydrogen. Now, our final unit, grams of hydrogen, is equal to what we want in our question. So I multiply everything at the top divided by everything at the bottom, and we should get that in 1.50 kilograms of water, there are 168 grams of hydrogen. Now let's look at the next question again. It is dimensional analysis. So I'm going to start with my train tracks. I'm going to start with what we know. We know that we have 2.70 moles of H2O. We also know, because of the molecular formula, for every 1 mole of H2O, we have 2 moles of hydrogen. It's written right there, H2O. Now for every mole of hydrogen, we have 1.01 grams of hydrogen, and that's from the periodic table. Now let's look at our units. Mole of hydrogen, cancel out. Mole of H2O, canceled out. So we're left in units of grams of hydrogen, which is what we want. So now we can start doing math. Multiply everything at the top together, divided by everything on the bottom, and we should get that in 2.70 moles of H2O, we have 5.45 grams of hydrogen. Alright, that's all for this video. See you in the next one.